Once again, hello and welcome to another episode of Differential Calculus with Sir R Squared. In this video, we're going to discuss about derivative of a function in parametric form. We are referencing Calculus with Analytic Geometry by Thurman Peterson. Learning Objectives and Outcomes. Ang pangunahing layunin ng videong ito ay maturuan ang mga mag-aaral kung paano mag-solve ng derivatives of functions in parametric forms. At ang kahihinatnan ay matututunan ng mga mag-aaral ang pagsosolve ng derivative of functions in parametric forms at magamit ito sa aktwal na aplikasyon na may kaugnayan sa siyensya, engineering at teknolohiya.
Disclaimer: ang bidyong ito ay ginawa ng may akda upang magamit sa pagtuturo ng matematika at maging sandigan ng mag-aaral sa kanilang pag-aaral ng kalkulus. Ang bidyong ito ay maaaring mai-download ng walang bayad or for free sa www.youtube.com. Ano man pong maling paggamit sa bidyong ito maliban sa nasa saad sa taas ay hindi po responsibilidad ng may akda. This video is not regulated by the institution. Any flaws in this video is at author's imperfection.
Let us start by defining what is a parametric equation. Diretso Tagalog na po tayo para hindi na po tayo kumusumo ng maraming slide. Yang daw pong mga parametric equation ay gumagamit ng mga independent variable na tinatawag nating parameters. At yun daw po ay open denoted by t. At yung mga independent variables ay defined as a continuous function ng parameter at hindi siya dependent dun sa mga ibang existing variables. Kung kinakailangan daw po ay maaari tayong gumamit ng isa or higit pa parameters. Meron pong halimbawa. Halimbawa po, ang equation na y is equal to x squared. Alam na alam po naman po natin na ang y dito ay ang dependent variable at ang x squared is the independent variable. Kung magkaganon, sasabihin po natin sa ganitong form na y is a function of x. This is in Cartesian form. Ngayon, pwede daw po natin yan i-convert sa tinatawag nating parametric form. Gagamit daw po tayo ng t as a parameter at sasabihin natin niya yung x is equal to t. At pagkatapos, pwede natin makonclude na y is equal to t squared. Ang pag-convert daw po to parametric form ay tinatawag na parametrization, which provide great efficiency when differentiating and integrating curves. So, sa susunod pong slides ay atin pong ipakikita, magkakaroon po tayo ng ilang halimbawa, kung paano mag-convert ng Cartesian form to a parametric form. Subalit aking pong ipapauna sa inyo na ang pag-aaralan po natin dito ay hindi yung parametric equation itself, sapagkat tinapos na rin po natin ito during our algebra days. Ang pag-aaralan po natin dito ay kung paano kumuha ng derivative ng parametric equation. Nandito po yung halimbawa ng circle at isinasalaysay po dito kung paano i-convert sa parametric form yung Cartesian form niya. Subalit, nagkaroon po ako ng susunod na slides na mayroong pong illustration para mas madali po nating maunawaan kung anong ibig sabihin nito.
Let me illustrate this, although this is not the focus of our study. Suppose in this first drawing, we have a unit circle with the center at the origin, here. Now, suppose that we are using a parameter of t, and we have a unit radius, which is 1. Let me try to grab a pen. Let us draw the triangle that was formed by that unit radius 1. We say at any point in the locus that can be at point x and y. We will now be drawing the parameter t here instead of theta. Sometimes ang parameter na ginagamit natin theta, but this case, let us use the parameter t to illustrate what is stated on the other slide. Now, if this is t, this one is x, and this one is y. And the hypotenuse side is r. We say sine of t is equal to the opposite side y over the hypotenuse side r. Therefore, y is equal to r sine t. Similarly, we say cosine of t, which is the adjacent side over the hypotenuse side, that is equal to x over r. And therefore, x is equal to r cosine of t. This is the parametric form, wherein the parameter is t. Notice that both x and y is now in terms of t. Now, what if the circle is not having the center at the origin? Kagaya nitong kaso dito sa pangalawang drawing. For example, this is a circle having its center at h and k. So meaning to say, from here to here will be h, and from here to here will be k. Now, suppose that we have a point here, x and y, so from here to here will be x, and from here to here will be y. Therefore, what will happen now? Now, in this case, ang gamitin naman natin parameter is theta para naman na masatisfy din natin yung iba, no? Let us use the parameter theta. And here, what is left here will be equal to, yes, you are correct, that will be x minus h. And here, what is left is y minus k. Of course, this will be the same r. Now, let us try to write the parametric equation here. We say sine of theta is equal to the opposite side, which is y minus k over the hypotenuse side, which is r. Cosine of theta is equal to the adjacent side, x minus h over the hypotenuse side, which is r. Therefore, y is equal to k, we transpose k to the other side of the equation, plus r sine of theta. And x is equal to, we transpose h to the other side of the equation, we have h plus r cosine of theta. There you have it. This is your parametric form with a parameter of theta. Narito naman po ang isang halimbawa kung paano i-convert ang isang linear equation sa parametric form. Y is equal to 3x plus 5 is a linear equation with y as the dependent variable and x as the independent variable. We say y is equal to function of x. And if we use t as a parameter, we say x is equal to t, we can now say that y is equal to the function of t. Therefore, if x is equal to t, y is equal to 3t plus 5. Sa ganitong paraan, yung ating pong dependent variable ay hindi na dumepende dun sa x kung hindi sa t na po siya nakadepende. Yun po ang kahalagahan ng paggamit ng parameter para pwede po natin siyang i-integrate kung sama-sama po yung mga variable. I hope with these two simple examples ay nakita na po natin kung paanong mag-convert. Bagamat ipinapauna ko po na hindi po ang topic natin dito ay ang
parametric equations, ano? Ang topic po natin dito is getting the derivatives of parametric equation. Yan pong mga pagkuha ng parametric equation, pagko-convert na yan, ay pinag-aralan naman po natin sa algebra.
Now, after having a glimpse of what we used to do in the past in the parametric equations, let us now focus on the main point of our subject matter, which is the parametric derivative or getting the derivative of parametric equations. In calculus, a parametric derivative is a derivative of a dependent variable with respect to another dependent variable that is taken when both variables depend on an independent third variable. Yun nga po yung t, no? Na ginawa natin kanina. That is, when the dependent variable are x and y and are given by a parametric equation. So, sulat po natin kung ano daw po yung mga formulas for differentiation dito. Normally, ang tawag natin po sa derivative is dy over dx. The derivative of y with respect to x. How are we going to get that in the parametric equation? That will be equal to the derivative of y with respect to the parameter t all over the derivative of x with respect to the parameter t. Remember, both x and y are functions of t. Therefore, they are differentiable with respect to t. In that case, t will cancel out and we will be having dy over dx. This is the first derivative. Now, what if we're asked to find the second derivative or yung tinatawag nating d squared y over dx squared? It is not as simple as getting the derivative of the first derivative. Although, gagawin natin yon, pero meron pa tayong kailangan gawin pang iba, no? The first derivative is dy over dx. Yun po yung first derivative na nakuha natin. We have to differentiate that with respect to t. But we are not done yet. In this case, we need to divide that by the original dx over dt. And there you have it. This will be your second derivative equation. Saan po makukuha yung dx dt? Dito po. Ayan. Now, on the following slides, we will be having examples to illustrate this further. We go now to the examples. Find the derivative of the following parametric equations. Number 1, x is equal to cosine 3t. Y is equal to sine 3t. We say solution. The derivative of x with respect to t is equal to negative sine 3t times du dx, which is 3. Therefore, we have negative 3 sine 3t. And the derivative of y with respect to t is equal to cosine 3t times du dx, which is 3. Therefore, we have 3 cosine 3t. Now, we are asked to find dy dx. Therefore, we have dy over dx is equal to dy over dt all over dx over dt. And therefore, what is dy over dt? That is 3 cosine of 3t all over negative 3 sine of 3t. And we will have 3 will cancel out. We will have negative cotangent of 3t. And we will have our final answer. We have example number 2. find dy dx for x is equal to 8 cosine t plus 5 cosine 4t. Y is equal to 8 sine t minus 5 sine 4t. We say solution. Dx over dt is equal to negative 8 sine of t and then negative 20 sine of 4t. Now, going to dy over dt, ito naman po yung i-concentrate natin. We will have the derivative of sine is cosine, therefore we have 8 cosine of t minus the derivative of sine is cosine, but yung du natin is 4 at may 5 tayo doon, negative 20 cosine of 4t. Now, if we're asked to find for dy over dx, it will be dy over dt all over dx over dt. Therefore, what is dy over dt? We have 8 cosine of t minus 20 cosine of 4t all over dx over dt is negative 8 sine of t minus 20 sine of 4t. If we try to factor out 4 on the numerator, we have dy over dx is equal to 4 2 cosine of t minus 5 cosine of 4t. And in the denominator, we will have to factor 4 also. 4 times negative 2 sine of t minus 5 sine of 4t. Therefore, 4 will cancel out and this will be our final answer. Number 3. If x is equal to t cubed minus 1 and y is equal to t squared plus t, find d squared y over dx squared. We say solution. Dx over dt is equal to, we focus on this one, 3t squared. And dy over dt, we look at this equation, that is equal to 2t plus 1. Therefore, dy over dx is equal to 2t plus 1 over 3t squared. But we are asked to find for the second derivative, which is d squared y over dx squared. Therefore, what we're going to do is to get the derivative of the first derivative dy over dx with respect to t and then divide that by the original dx over dt. Alright, let us try to do that. We substitute it here. We say d squared y over dx squared is equal to the derivative of this function here. So by quotient rule, we will have yung denominator will be 9t to the fourth agad kasi 3t squared. And then we have 3t squared, copy the denominator, times the derivative of the numerator, which is 2, and then minus the numerator, which is 2t plus 1 times the derivative of the denominator, which is 6t. Therefore, what we'll have there is, let us try to simplify first this numerator. Here what we will be having will be 6t squared minus 12t squared minus 6t over 9t to the fourth. But of course, that will be over the original dx dt, which is 3t squared. This will be over 3t squared. Okay, simplifying further, we will have d squared y over dx squared is equal to negative 6t squared minus 6t over 27t to the 6. Let us try to factor out negative 6 in the numerator, negative 60. We will have t plus 1 all over 27t to the 6. Now, we try to reduce to simplest form. D squared y over dx squared will be, by 3, this will be negative, t will cancel out, so mawawala na tong ting to, negative 2 times t plus 1 all over, ito ay by 3, 9, yung t na na-cancel out na isa will be t to the 5th. This will be our simplest form and this will be our final answer. Number 4, if we have a literal constant a and b, x is equal to at and y is equal to bt squared, find dy dx. We say solution, dx over dt is equal to a, dy over dt is equal to 2bt. Therefore, dy over dx is equal to 2bt all over a. And this will be our final answer. Number 5, x is equal to sine squared t and y is equal to cosine squared t. Find dy over dx. We say solution, dx over dt is equal to, we can rewrite this one first as sine t quantity squared. We will have chain rule here, 2 sine t times the derivative of sine t, which is cosine t, times du, which is 1. Therefore, we will have here 2 sine t cosine t. But this falls under an identity which is sine 2t. Now, finding the derivative of y with respect to t, we will have cosine squared t. This can be written as cosine t quantity squared. So when we have the chain rule, we have 2 cosine t times negative sine t times du. So what will happen is we will have negative 2 sine t cosine t, and that falls under the same identity, but this time it will be negative sine 2t. Therefore, the derivative of y with respect to x, or dy dx, is equal to negative sine 2t all over sine 2t. And that will be equal to negative 1. And this will be our final answer. Number 6. If x is equal to sinh t and y is equal to cos t, find dy dx. We say solution, the derivative of x with respect to t, or dx dt, is equal to cos t times 1. and that will be equal to cos t. The derivative of y with respect to t is equal to positive sinh t multiplied by 1 because that is du over dt, and that will be equal to sinh t. Therefore, the derivative of y with respect to x is equal to the derivative of y with respect to t all over the derivative of x with respect to t, and that is equal to sinh t over cos t, and that is tan t. And this will be our final answer. Number 7. X is equal to t minus t cubed, and y is equal to 2t plus 5. We are asked to find for d squared y over dx squared, or the second derivative of the parametric equation. We have the derivative of x with respect to t is equal to 1 minus 3t squared. The derivative of y with respect to t will be equal to 2. Therefore, the derivative of y with respect to x is equal to the derivative of y with respect to t all over the derivative of x with respect to t, and that is equal to 2 over 1 minus 3t squared. But we are asked to find for the second derivative d squared y over dx squared. Therefore, what we're going to do is to take the derivative of the first derivative dy over dx with respect to t and divide that by the original dx over dt. Let us try to do that. Here, we are going to get the derivative of this function. So we will be having a quotient rule. Therefore, d squared y over dx squared is equal to, ano po ang magiging quotient rule niyan? 1 minus 3t squared quantity squared pa ulit. Pagkatapos kopyahin natin yung 1 minus 3t squared, and then we have to multiply that by the derivative of the numerator, which is 0. And then minus the numerator, which is 2, times the derivative of the denominator, which is negative 60. So what we will have is equal to positive 12t over 1 minus 3t squared quantity squared pa. And then this will be over the dx dt original 1 minus 3t squared. And this will be over 1 minus 3t squared. Ayusin lang po muna natin tong equality sign na iwan sa taas. So, d squared y over dx squared is equal to, let us try to simplify, 12t all over 1 minus 3t squared times or raised to the third power, kasi 2 plus 1 will be 3. And this will be our final answer. Well, I guess it's time for me to park my pen. Generalization na lang po tayo, no? Paulit-ulit lang naman po, no? In parametric derivatives, the first thing you do is get dx over dt, and then get dy over dt. And to get dy over dx, you simply have to divide dy over dt by dx over dt. Sa-substitute mo lang dito sa numerator at sa denominator. And then, if you're asked to find for the second derivative d squared y over dx squared, what you're going to do is to get the derivative of dy over dx with respect to t and divide that by the original dx over dt. And the rest is history. Ngayon, sa pag-derivative naman, lahat na yun applicable, Marunong na kayo ng product rule, marunong na po tayo ng chain rule, quotient rule, power rule. So, pare-parehas lang po, It will be the same process over and over again. At pagkatapos, marunong ka na naman kumuha ng derivative of transcendental functions, which is trigo, inverse trigo, yung exponential, logarithmic, alam na rin po natin yung logarithmic, at meron na rin tayong hyperbolic and inverse hyperbolic. Tawagin na lang po natin ang hyperbolics. Basically, it is just the same, but the main point is, first, get dx over dt, and then get dy over dt, divide dy over dt by dx over dt, you will have dy over dx. And then, if you're going to take the second derivative, you take the derivative of the first derivative and then divide that by dx over dt. And that will be your general operating procedure. So, with this, I hope meron po tayong natutunan kahit konti sa pag-treat ng derivative ng parametric equation. Now, kung hindi po given sa parametric, dun po sa bandang una, nireview ko na rin naman po kayo kung paano i-convert. At sa wakas ng lahat ng bagay, tayo po'y magpasalamat sa Panginoon Diyos sa pagbibigay sa atin ng lakas at buhay upang mapag-aralan at matutunan ang mga bagay nito. Ang lahat ng parangal at papuri ay sa iyo, Diyos amang makapangyarihan sa lahat, na naghahari noon, ngayon at magpakailanman, magpasawalang hanggan. Amen. To God be the glory.